So let's talk about it, 'cause creams and ointments are exciting, the smoothest of all dosage forms, and also probably one of the most important. I would tell you, if you're ever going to have to compound anything in a retail pharmacy, it's probably going to include some sort of topical cream or ointment that you need to mix or do whatever with. So an important one to kind of go through. So question to you to start off with is the difference between a cream and an ointment. And this is somewhat important for you because you're going to have to type a label, right? You're going to have to type on the exam drug name, strength, and dosage form. And whatever you make, I'm going to hold you to correctly calling it either a cream or an ointment based off of the modern definitions for that. The reason it's confusing is that one of those terms have been around forever, and it's ointment. Okay, and it can really apply to any semi-solid dosage form. However, we have kind of divided ointments and separated them away from cream. So let's make sure, and the official definitions are up there, but they're not all that helpful. What I need you to do is be able to identify an ointment. Can somebody tell me a good property of an ointment, not that separates it from a cream? An ointment would be greasy, absolutely. Thick, it's kind of stiff, tend to be yellow. So what's a hallmark to kind of visualize in your own mind is Vaseline. Have you ever seen Vaseline or maybe Aquaphor? We're going to be doing Aquaphor up here for the dry lab. It is thick and it is stiff. It is a yellowish color. It is greasy, occlusive. Does everyone know what occlusive means? I'll give an example of that here in a minute. Occlusive, all right? Separate that from a cream. Most importantly, what color are creams? They are not yellowish. They are white. They are soft. They rub into the skin. They kind of disappear. They're not occlusive. They don't cover the skin because they rub into the skin, okay? They're water washable, whereas the ointments are not. So it's the properties of your base that will determine whether you're going to call it an ointment or a cream. So make sure that you do know and can identify based off of the properties. Because the properties are important. Okay, so here's an example. Somebody comes to you and they have a cut or a scrape on their skin. And you go over there and you have both Neosporin cream and Neosporin ointment. All right? Same active drug, same antibiotics kind of in both of those. Would you recommend the cream or the ointment? Or when would you pick the ointment over the cream? Have you thought about this? They both work. I'm not saying one's wrong or the other, but here's the deal. If I was a pharmacist, I might recommend the ointment because here's the deal. The properties I would like is I want the drug to be put onto the skin and kept on the skin. I don't want it to rub away. I don't want it to wash off. And I like the idea of the ointment being occlusive and covering the skin or covering the cut area to keep things from getting into it while it's healing. See what I'm saying? I'm looking at some of the properties that the ointment would convey in addition to the antibiotics, where the cream will kind of rub right in and it'll deliver that antibiotic, but then it's probably going to wash off or sweat off, and then it's going to be left exposed until the next time I put some more antibiotic on there. But there are different times where you maybe want the other situations. So again, it's never one that you just always want to use ointments, but look at the properties of the base. And it's also why the base is part of the label. When we talk about your label here today, you're going to say drug name and strength. You're going to say in whatever the name of the base is, because that does convey properties to the final product. So to that end, you're going to need to know properties about your bases if you need to select them. But more important for the exam, in the end, here's the deal. We're going to talk about levitation. That you have to take your solid. Here's the problem. What did we do last week? You took a solid, right? You ground up your powder, so you had your drug in a powdered form, and you needed to liquefy it. If you weren't careful, what happened with that powder when you added it to the liquid? It tends to form what? Clumps, right? The same exact thing happens when you put powder into a semi-solid, which is just kind of not a liquid, not a solid, but something in the middle, okay? So a semi-solid, it'll form clumps. So what are you going to do to keep your powder from clumping as you put it into your semi-solid base? What you're going to do? You're going to wet it. It's the same idea. But because this is a new week, we're going to make you memorize a new term. So, and don't ask me why, but there's a special term that we use for wetting powders when you incorporate them into topical creams or ointments. So you guys know what it is? Levigate. That's the idea of levigate. I just want to make sure you understand. When we talk about levigating, you are going to have to use the term levigate in your procedure. What does levigate mean? Wet the powder. Basically liquefy the powder so it can be dispersed into the semi-solid base without forming clumps. Okay, there are two different ones I'm going to tell you that you're going to have to memorize to know which one to select. The selection is based off of the type of base. All right? So hopefully if you, anyways, the podcast did go through a lot of detail on these, but you need to know them a little bit. There are multiple different types of bases that you can lump together. The ones on the test, I have the right to use any of these brand names. I'm going to put some jar of thing out there, whether it's a cream or an ointment. I'm going to label it with one of these brand names. Okay, you must be able to go from the brand name to the type and classification of the base so that you can select the correct levigating agent. Are you with me on that? Why you need to kind of know this, okay? So starting at the top, the oleaginous ones are the ones that are all basically lipid. There's no water in them, and they're basically a petroleum-derived product, okay? This is Vaseline, white petrolatum, and white petrolatum just is less yellow because they take out more of the kind of petrolatum stuff so it doesn't stink quite as bad. But essentially, it is the classic of an ointment. And I will never forget, at the med center, I had a prescription for 5% LCD, which is this liquid goo stuff that you're going to see here in the dry lab here in a little bit. But it's a liquid that needed to be, 5% of that needed to be incorporated into Vaseline. The prescription was for Vaseline, right? I didn't know all of this as well back then, so I just took my Vaseline, make a little divot, added my stuff, and squish, 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 and then squish, 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 and then looked at it, and then I squish, 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 squish again, and I stopped, and it just puddled. It really just puddled on top of the Vaseline. That liquid would never go inside there. It was a huge failure, okay? So we had to call the doctor. It was like, doctor, this is not working. What else can we do? And we thought about it, and we came up with the second category. So the reason there is anhydrous absorption is because the petrolatum or the oleaginous bases are good, but are problematic for incorporating drugs. Anhydrous absorptions are the same kind of base that now we can incorporate more drugs. All right. So the hallmark, and again, you got to know all of them, but the one that's really helpful to remember is Aquaphor. Have you ever heard of Aquaphor? What is aqua? What does that stand for? Does anyone speak Spanish? Okay. Water, right? So is there water in Aquaphor? What is the class, though? It's called a what? Anhydrous absorption. What does anhydrous mean? No water. There is no water in Aquaphor. Why did they call it that? What does the PHOR stand for? That suffix, like ionophore, means loving. So Aquaphor is water loving. What they've done is taken something like Vaseline and add a bunch of emulsifiers to it. So now when you squish, squish, squish your liquid in there, those emulsifiers can help kind of disperse that liquid within that oil-based semi-solid. So it makes so that it can suck it up. And you're going to see that today. That's what we're going to illustrate to you in the dry lab. We're going to take the same script with the LCD, put a little bit of it on the Aquaphor and mix it up, and you'll see it just incorporates into the base beautifully. So to be honest with you, from a compounding standpoint, we tend to use more of the anhydrous absorption bases than we do the oleaginous. They're just easier to be able to incorporate drugs and yet still have some of the same properties. Step down one level, and we learned about emulsions, right? You know about water and oil versus oil and water, right? Which one is the internal phase? The first, right? So if I say oil and water, then oil is the internal phase. If I say water and oil, then water is the internal phase. There are emulsions. I mean, basically these are semi-solids that are combinations of both oil and water components that have enough emulsifiers to mix them. In one sense, we have it as a water and oil. Why would we want a water and oil? And this is like Eucerin. Have you ever heard of Eucerin? Eucerin's not as yellow as Aquaphor, right? It's whitish, but it's not pure white. It's not a bright white. And notice that some of that is because there's definitely an oil base in the external phase. It makes it stiffer, so it doesn't wash off quite so easily. And it doesn't wash off. It's got some oil in there, so while it will wash off, it's not easily water washable. It won't sweat away quite as easy. It tends to stay in contact with the skin a little bit better and longer than the last one that we'll talk about with the oil and water. Since it's a water and oil, the Eucerin sticks around, is a little bit stiffer, and doesn't wash away as well. Okay? On the other hand, there are things like what you're using today for your wet lab, which is the aquaphilic ointment, Dermabase, Velvicol. These are the opposite. These are the oil and water, where water is the external phase, which means they're definitely the brighter white in color. They're much softer and not nearly as stiff, and they rub right in. Okay? Going back to it. If you wanted to hydrate the skin, what would be a good base? A oil and water, right? So that would provide the water component to be actually to hydrate the skin. If you wanted to be occlusive and keep the skin from losing water, keep it from losing that moisture that was in there, so you would put something like a Vaseline that holds the moisture in. So once again, I'm just trying to make sure you understand the base does contribute to what it's going to do outside of the actual chemical or drug that you include into it. Okay? Any questions about that? It's a brief view. I'm sure you got it down, but brand names converted into what? Classes, because now we're going to tell you what you're going to need to know about that. As I said, since we have to levigate our solids, if there's not something in the formula to be able to levigate with, we are going to add what we call an external levigating agent. And there are multiple things you can use, but these are the two most common. And the only two I'm going to hold you to is when to use mineral oil or when to use glycerin. All right, the long story is it needs to be compatible with the external phase. So if oil is the external phase, meaning oleaginous anhydrous absorption, or water and oil, any one of those three categories, which of those two levigating agents do you think is going to be compatible with the oil phase? Mineral oil, okay? If you're in the oil in water or a water-soluble base, then you're going to want to not use mineral oil. That's when you would use glycerin, okay? Could you not just use water to levigate something with? Why don't we just levigate the water-compatible ones with water? You could, but have you ever tried to use water on a pill top? It splashes everywhere. It has such a low surface tension, it would run everywhere. It would be very difficult. You're going to get to use glycerin today, and I just want to bring it up so that as you're using it, look at it. I want you to think of glycerin as basically sticky water. It is essentially primarily water, but it has a much higher surface tension, so it's easier to work with. It just doesn't splash out as you're working and spatulating on your pill top. So it's a much more effective, ingredient to use. Any questions? Last thing I'll try to say, next week on the exam, I'm going to throw some random base out there. You have to figure out that from based off of the brand name of that base, which category it is, which class, and based off of the class of base, which levigating agent to use. Are you okay on that? That's the hardest part of the test to some extent. Not even that hard. All right, the only other thing I won't remind you of, but you should definitely come away today understanding, is that you have to compound for excess. Even if you're really, really good today and using that parchment paper, stuff sticks to it. Some of it sticks into the weigh boat. Some of it sticks onto your spatula. There is a significant amount of loss. You really do need to calculate for excess. So we're going to base all of our calculations on 10% excess and be lucky to be able to dispense the prescribed amount within the 5% error. So make sure you base all your calculations on 10% excess. And the last thing is today, the last two steps in your procedure that you're going to write, and then in fact that you have to do, is when you transfer all of your product into, and in this, for once we're not using weigh boats, you are going to really be putting them in ointment jars. You're going to put it in, slap it in, and slap it in, and slap it in, and Judy will show you how to do this. When you're all done, you need to what we call both clean the ointment jar, which means, is the ointment supposed to go on the inside of the jar or the outside of the jar? Telling you, some of you, it's all slips out of our hand as soon as we pick it up. So make sure it's nice and dry on the outside. There's no slimy stuff on it. And then you're going to open up the lid, and you are going to dress the ointment. And that's not a little tutu thing. That's where you take the spatula, if you watch the video, and you circulate it around and smooth the top and make a nice little Dairy Queen lip on it. Okay? We want a nice finished product. So you are going to label your procedure to clean the ointment jar and dress the product, as well as, in fact, do that. So we'll show you that, but don't forget that step. Sometimes people do. All right, so we do the dry lab. Let's do it, man. So turn to the dry lab. We'll read and interpret it as you're filling out some of this information down at the bottom. So again, realize the formulation record isn't on the test just for the sake of time and you not being able to look up stuff. So Sylvia Jones has been prescribed LCD 5%, hydrocortisone 2.5%. So the two drugs are going to be combined. We're going to put that into the base of called Aquaphor. And QSAD up to 30 grams. What does the QSAD stand for? Up to a total of 30 grams. So our final total weight of all of the ingredients and the Aquaphor together should max out total at 30 grams. All right? So again, LCD is used quite a bit topically, both in compounding and commercial products. Anyone, shout out if you know what LCD stands for. Has anyone used it? Anyone compounded with it? Not uncommon. Liquid carbonic detergent, liquid coal tar. Have you ever heard of coal tar solution? It sounds and smells as bad as that seems like, because it is yellowish, stainy, stinky stuff. It is derived from coal, and it is very useful for psoriasis and eczema. And again, not for rather more moderate to severe cases. Combine that with an anti-inflammatory and hydrocortisone, and keep that. Use a thicker base that'll keep it right on top of there. Keep you from staining clothing and so forth by having a little bit of a thicker ointment on top. So, anyways, that's our formulation. Let's make that. Looking at the additional information. I'm reminding you today to make 10% excess, but I will not put that on the test. I expect you to remember that. The only other things listed there are specific gravities, and I will always provide you, if you have any liquid products, I will always provide you the specific gravities. It's not anything you ever have to memorize. The reason I'll bring it up is let's look back on here. The other thing in terms of your interpretation on the prescription, in topical products, the percentages given to you are always going to be weight per weight. Okay? So the LCD 5% is a weight per weight. But what did I say about LCD? What is it actually? It's not a solid, it's a liquid. So can you weigh a liquid? Yes, we did that before, right? But that's a big pain in the butt. So we don't want to do that. I've given you the specific gravity so you can convert the weight to a volume so you can easily measure that. So That's where the specific gravities come into play. All right, so we got the specific gravity for LCD, and let me just get this out of the way. They always give us specific gravities with no units. Does specific gravity have units? It doesn't. Okay, so what specific gravity is kind of stupid. I'm just saying. You can record me saying that because what is a specific gravity? Isn't it a density? What's the difference between specific gravity and density? It is the density of the liquid divided by what? The density of a reference substance, which is water. And what is the density of water? 1. So the number for the specific gravity is the same number as it is for the density. But what you need to know is the density because you need to know the units. What are the units for density here? For example, the specific gravity of LCD is 0.87, which means the density is 0.87 grams per mil. So remember the units of density. So if you look at specific gravity, if I were you, I'd kind of write the units right next to that. That number, if you use it, is because you're going to need the density, which is in grams per milliliter. Okay, and you are going to need to use those numbers at times. Okay? Any other questions? So why did I give you specific gravity for glycerin and mineral oil? Will you ever need to use both? No. Who's going to decide which one to use, if to use it at all? You. So again, whichever one we do. And let me just ask you this. If you do use, let's just say we used a milliliter of mineral oil to levigate this. Okay? Does that mineral oil volume have any weight? Yes, that's the point of the specific gravity. Would we have to account for the weight of our levigating agents? Yes, you do. So that's why that information is provided to you as we go forward. Okay? Any questions on this so far? Alrighty, you're already answering. Let's talk about the ingredients here real quick. Let's just finish up and make sure we know. So the hydrocortisone we are using is a powder. It's a solid, so that's nice. Whatever grams of hydrocortisone we need, that's all we're going to weigh out. Okay. The one thing I will tell you now about hydrocortisone that's different than your urea that you're going to be doing in the wet lab is hydrocortisone itself comes naturally very light and fluffy and very fine particle size. There's no reason to have to reduce the particle size of hydrocortisone. That's unusual. When you do your wet lab, I'll talk about it, you're going to need to triturate that powder down to a fine powder. Because remember, just like when we were making our suspension, you need a fine powder to be able to use this. But we're good for hydrocortisone. LCD we said was a liquid, and then we're going to be using Aquaphor. So let's go ahead and do our beyond use date. Circle the shortest expiration date on there. Let's get that out of the way. So here, if I look at my ingredients, so 9/2019 is the shortest expiration date. So the trick on this is, though, is it 9/30 or 9/31 of 2019? Okay. Is that even right, though? That is the shortest expiration date, but is that past the longest amount we can assign per USP 795? Remember what we said last week? It's going to be 14 days. Oh, wait a minute. But that was for suspensions. I'm just trying to make sure you remember, right? With suspensions, it was 14 days refrigerated. What is it for a topical cream or ointment? 1 month. 30 days, 1 month. Absolutely. 30 days, 1 month. And for me, just change the month. I don't care if there's 30 days or 31 days. I'd screw that math up. Just change the month digits. So what is today? Isn't it the 24th? So 25th. Hey, I'm losing. I'm sorry. So 25th. So today is 4/25 of 2019. So your beyond use date is 5/25 of 2019. Okay? So that would be your beyond use date. Gosh, I messed it up. All right. Any questions on that? Not hard, but remember 30 days for topical products. All right, so let's do some calculations, man. Get your calculators out. Don't just watch me do it. I can do it, and I'm not even taking the test. You're the one on the test next week. Make sure you can do this. One thing I will correct on my calculations here just a little bit is I skipped a step. I put steps 1 through 4. Step 1 is the required weight of LCD. We actually have to do something before that. So put in step 0.5 somewhere. So step 0.5 really is this. How much are we going to base our calculations on? So wait a minute. So what are we going to dispense? We're going to dispense 30 grams, right? But our calculations are going to be based off of the preparation of 10% excess. So do this however you want. Multiply that by 110%, or 1.1, to actually know what we're going to base our calculations on. So we're not going to base them on 30. What are we going to base them on? 33 grams. That's what you all got? Okay. Now, so remember that. Don't ever go back to 30. We are going to do all of our calculations based off of 33. So let's start with the LCD. It's not hard, but it's got kind of a two-step process. Because really, what did the prescription say? It said to make our 30 grams have what percent LCD? 5% weight per weight. So again, if we're going to start with 33 grams, let's multiply that by the 5 grams of LCD. over 100 grams of ointment. Okay? That's basically 5% weight per weight. Well, what does that equal? You're going to wait a little bit anyway, so you might as well just do the breakdown. Everyone get something like 1.65 grams of LCD? Trick to remember is that is grams of LCD. So the next L, so let me write that down here. That's our weight, 1.65 grams. Now we need the volume, so let's convert that to volume. That's where we're going to go back to that specific gravity and convert it to density, basically. And say that my 1.65 grams of LCD times, and again, I want to set it up so my grams cancel. So you got to put per 1 milliliter on top over the 0.87 grams of LCD. Wait, grams of LCD cancel, and you tell me what the final answer is in milliliters. Got 1.9 milliliters. Okay. Any questions with that? Just hard because he had to do it kind of 2 steps to get to volume. And that's how we will measure it from, is measuring the volume. So go ahead and do the hydrocortisone. That's an easy one. It's very much like the weight thing we just did for LCD. I'll give you a minute. I'll write my answers down. Everyone get 0.825 grams of hydrocortisone. 2%, so if I just take, or 2.5%, I'm sorry, 2.5% times 33 grams is 0.825 grams. So that's how much hydrocortisone we need. So how do we figure out how much aquaphor we need? If the total weight is supposed to be the total weight, then wouldn't you just take the total weight, subtract each of the other ingredients, and what's left over is the amount of base you need? Easy peasy, right? So let's start with that. So our total amount is going to be 30 grams. From that, let's go ahead and subtract the amount of hydrocortisone, which we said 0.825. Okay. Oh, did I mess something up? So do you see at this step, one of the most common mistakes is to revert back to the total weight of being 30. And you're absolutely right. That is totally wrong. Bad Larry. So let's go back to 33 grams. That was our total. Subtract out, I don't think I messed up any of these things. Subtract out the hydrocortisone. Let's subtract out the LCD and then see what's left. Some people are shaking their head. Did I do something else wrong? I subtracted the volume of the LCD, not the weight of the LCD. Also a very common mistake. So remember to be careful. That's why I didn't put my units down. So what we need to do is subtract the weight. So now for the weight it was 1.65. Now I don't think I've screwed anything else up, so go ahead and tell me how much aquaphor we need. Subtract all that out. Everyone get 30.525. Or did I screw anything else up? What possibly else could I have screwed up on that? Wait a minute. What did we say hydrocortisone is? It's a powder, right? It's a solid. So aren't we going to have to levigate it? Yes, we're going to have to levigate it. So what levigating agent should we choose? If we were going to use an external levigating agent, given the base of aquaphor, which levigating agent should we use? Mineral oil, very good. And I'm telling you, you're going to see now that you don't know how much to use until you actually levigate it. Depends on the amount of powder. The more powder, the more levigating agent. We'll talk more about that here in a minute. Let's just say right now, though, if we needed to levigate this with 1 milliliter, then what would the weight of that 1 milliliter be? You go back to the specific gravity on the front page, right? For mineral oil, it's 0.88. or yeah, 0.88. So wouldn't we also need to subtract 0.88 grams for the 1 milliliter of the mineral oil? All right, so I ain't doing it though. I ain't doing that. Why not? Well, how did I describe glycerin and mineral oil? What kind of levigating agents are they? External. Did the doctor prescribe them in the order? Can you just add something the doctor doesn't prescribe for? You can to formulate it. Are you with me on that? In this case, the only way you can get the powder into the cream or ointment is to levigate it. So yes, you can add that. But should you add something external if there's already something in the formulation that could be used to levigate the powder? Is there any liquid being called for in the compound that could serve that role? And the answer there is yes. The best formulation for this product would be to levigate the hydrocortisone with the liquid LCD that's already going to be in the formulation. Therefore, no additional requirements are needed. Okay? However, if LCD wasn't in there, or if LCD wasn't a liquid and we had just solids, yes, we would have to choose the most appropriate levigating agent and subtract the weight with that. But since that's not the case here, we're good. So let's go ahead and go back to your compounding record, because essentially we have the targets for all of our ingredients. So let's write those down. Going back to here, we know our target for hydrocortisone is 0.825 grams. We know our LCD is 1.9 milliliters. And Aquaphor was 30.525 grams. We now know the amounts of everything we need. So give me a second to get set up as Judy gets us ready to make it. What you need?
Tissue box.
Oh, what do you?
Oh, this. Oh, keep that. There's one behind here.
I'll go get someone back.
Oh, okay. All right. All right. Soon you will know. Soon you will know that why I. Thank you. Soon you will know that why I need this tissue box. This is one dosage form that you can probably need your tissue box a lot. All right, so let's do a few measurements. Let's start with hydrocortisone. What is my target weight, by the way? 0.825. There.
All right, I went up one more. Okay, your actual, let's put down our actual for the hydrocortisone at 0.832. Actual for hydrocortisone is 0.832 grams.
All right, so we measured hydrocortisone. The next one we're going to measure is Aquaphor. So I'm not going to use the spatula here because it's dented, curved. It's harder to clean, so I'm not going to use a scoopula here. I'm going to use a spatula to measure it. All right, and what is my target weight here? 30.525. Okay.
Ooh, what color is that? A little glary. Now, do you see where it's kind of what I mean by a little bit yellowish in color? And she puts some up there. Do you see it? Ooh, look at it standing straight up there because it's kind of stiff. So it's yellowish, it's stiff, it's greasy, it's not water washable, it's an ointment. That is the definition of an ointment.
All right, we are happy with this measurement.
Actual 30.595. 30.595 for the actual for the Aquaphor.
For your spatula, it will be really hard to wash it today because it's so greasy. That's why you want to use your tissue to just wipe off. All right, this is ready. So the next one is LCD. We are going to measure by volume. So let's use a weigh boat to pour some out. And let's set up a volume. So what is my target volume here? 1.9. Okay, so let me get more than what I need.
Hopefully this won't be the splash zone in the front row again today.
All right, perfect. So this is ready. And before the whole room smell LCD, let's put this back first.
While Judy's doing that, I want you to change, look at step 3 in your procedures, an important change to some of the terminology. So starting on the, and 2 things to do. So starting on the first sentence, midway through where it says, and wet the powder, circle the word wet. That is what you're doing, but that's not the most appropriate term. So change the word wet to what? Levigate. What she's going to be doing here in a minute is levigating, which is in fact wetting. Then lastly, the start of the second sentence where it says spatulate, circle that word. That is an important term you have to use in your procedure, and she'll be doing that up here, so she'll talk about it, but make sure you do realize that's an important key term.
All right, Larry, can you make this a slide bigger?
So, you know.
Oh, come on.
Let me line up there.
Okay. All right, so we're going to do levigation here. So you can use your...
Paper.
Oh, yes, that's right. I forgot about that. So first of all, when was the last time you have to use a parchment paper? When you made capsules. All right. So when you made the capsules, you use this parchment paper already. One more time. For me, I have to use a ointment slab underneath it because I have a little diaper here, which is too soft for me to do spatulation. You don't have to do that. You can tape down a piece of parchment paper on your bench directly. That's it. However, last time, I probably did not emphasize enough for you that you have to tape 4 corners down really well, because if you've been lazy, tape only 1 or 2 corners, you survived, that was fine, right? For today, please don't be lazy. Tape 4 corners down, because you're going to work very much a lot of activity, spatulation on that whole piece of paper, all right? Of course, we will tell you that don't try to use the whole piece of paper, but you do a lot on that piece of paper. Therefore, don't be lazy, because you will find out that it's really hard if one corner is not quite taped well. Okay? All right. So you know how to do it. The levigation here is that I transferred my hydrocortisone powder on the parchment paper. I'm going to make a little dip. We are going to use LCD for levigation. So I'm going to add a little bit there and use my small spatula, okay, to do the levigation here. All right, clearly I still have a lot of powder, so I know I'm not there yet. All right, we will tell you what does it mean that when it's finished.
See where it still looks a little flaky? Powder chunk. So go ahead and write this in the margin. This will be definitely a big thing for your wet lab here in a little bit, because you're going to have to figure out yourself when to stop levigating. What we want is 3-word description of what it looks like when it's done. It should be shiny, sticky, glob. You want a shiny, sticky glob. That's when you're done levigating, when you've added enough liquid that it is both shiny because of the liquid part to it, it's sticky because the liquid holds on to it, and it's not so thin that it runs everywhere.
All right, so I have made mine, okay. Did you guys see the reflection of light? It's a little shiny on the top, right? I have made a paste. It's not looking like a puddle, but it's not too thick, somewhere between thick and too loose. So I made my paste already. That is called, what is the term you need to remember? Levigation. All right, so this is the time I'm going to mix my levigated chemical here with my base. All right, so I'm going to add about roughly 1-to-1 ratio. What is the term you need to remember for 1-to-1 ratio? Excellent. You haven't forget about that yet. Okay, so I'm using my small spatula. Try to mix up. All right. And it seems fine for right now, because with the amount of base plus drag I have, it looks like a small spatula is working okay. All right, but your larger spatula probably work even better. All right, guess what? These 2 spatulas, they can help each other. All right. So another 1-to-1 ratio. Let's add a little bit more. I want to use my larger spatula.
Now, how come she's not spreading it out across the whole parchment paper? Why is she just sticking right there in the middle? Ish. The more slathering around the paper you do, the more loss there is. And so while you can certainly spread out as you need to, try to avoid just using up the entire surface area, or you will have more loss because you'll probably slather it onto the countertop too.
All right, so let's add one more addition. Okay, I wanted to get everything out from my whey boat, because if I don't, those are considered part of my loss as well. All right, so I wanted to get as much out as possible.
And when she's finishing it up, and you can kind of watch her do that, I want to point to steps. Well, never mind. Hold on. We're done.
Okay, so this is called a spatulation. All right, I'm trying to mix well. I want to make sure my mixing here is uniform between hydrocortisone, LCD, and the base. All right, the more base I have now, the area on the parchment paper I'm using is clearly increasing. But I'm not really using the whole piece of paper, as you can see. I'm trying to stay as locally as possible.
Make a big glob here real quick. So,
yep.
As you're doing this, what was the point of the levitation? We wanted to avoid what? Chunks. Would you agree? You want to make sure. So as you're doing this, what you're going to want to do when you think, okay, am I doing pretty good? You want to slather to make it kind of a thin base there. And uh-oh, there is a spot right there. Can you see that little spot right there? There's a little spot right there. So do you know what you need to do? Watch this. It's not magic. Don't start from up here. Just go right over and watch. We're ready. Watch. What am I doing? See the bend in the spatula? The official term is squishing. You're going to squish down really firmly and then do a little circle. So gather the stuff over. When you see a little spot, something that needs to be broken up, you squish it down firmly and rub it. Some of you just kind of push it around. You need to make sure you squish down hard and rub out, not a mafia thing, any sort of chunks. And especially when you're mixing two different creams today with your wet lab, they're not the same consistency. You need to kind of squish them together and put some force to basically break them apart. So as you're doing that, you got to be looking for and trying to break up any inconsistency. So it's all nice and homogeneous.
Okay. Although be very careful, because you don't want to break your parchment paper. Okay. You don't want to have a little hole on your parchment paper. So this is important. You need to apply a certain amount of force, but do not break your paper. All right. Are we ready to transfer? Can we go ahead and transfer now? Not quite yet. What did I forget?
Step 5. Look at step 5. And I guess my question is, did we add all the LCD when we levigated? Why couldn't we have just gone ahead and add the rest of that LCD right when we were levigating? What would have been the problem with that? It would have run everywhere. Would you agree? There wouldn't have been any liquid or anything solid to hold on to that. So that's why now we're going to add the remainder of it.
All right. So I'm going to watch the magic here. It looks so oily, but then it could absorb the moisture for you, or water for you. All right. As much as I try, my area on the parchment paper has increased already. All right, and then you just need to do your best. Try to not use a whole piece of paper. Okay, so let's add the rest all together. And let's spatulate again. I hear that.
So as she's finishing up on that, what I wanted to get through is look on steps 6 and 7. There are 5 points on the exam in those 2 steps alone. You miss any one of those 5, any one of those things, you can lose up to 5 points. So realize step 6. Circle the word where it kind of says 30 grams. Circle 1 ounce. Circle ointment jar. Because you need to say to transfer how much? 30 grams. To a what size? 1 ounce. Saying what? Ointment jar. 3 different parts to that one sentence. And then down below that, Judy's going to show you here in a minute, you need to both clean the jar and dress the final product. So clean and dress were the kind of key terms within those 2 steps as well. So don't leave those out of your procedure, for heaven's sake.
All right, so let's gather everything together in the middle. We are ready to do transfer, okay? And I literally want to gather everything together, and you know why I need to do this very soon, because it's possible that we may end up not having enough. Okay. All right, so here is the ointment jar. What is the weight I need to dispense? 30 grams. Great. So I have this 1 ounce bottle here. perfect. 30 grams is roughly 1 ounce. I don't really need the weight of the bottle. Therefore, I need to tare with the bottle. You can tare without the lid or with the lid. Either way is fine. If you tare without the lid, you measure without the lid. If you tare with the lid, you measure with the lid. So either way is fine, okay? All right, so at this point, you want to use your small spatula to kind of take a small chunk, okay, add into your bottle. But guess what? Does it really go to the bottom bottle automatically? It doesn't. It's pretty stiff. So what do I need to do? All right, I need to tap on the bench, and you do the same thing.
Where I would remind you, where does the ointment go? The inside. So use the smaller spatula. Don't try to glob it all in there in one go. It'll stick and get everywhere. So try to put smaller chunks. Get it in the middle.
All right.
It's not as awesome when you all do this at the same time. It sounds like a herd of woodpeckers.
We'll probably change this as a drum class. Okay, let's add a little bit more. How much do I left over here on my piece of parchment paper? Not that much, all right? So I can, maybe I want to see, am I really there? Let's see my weight.
So let's do on your QA, write the range. You don't have to, but let's write down the acceptable range. Certainly on the test, you need to be within what area do we allow you? 5%. So what is 5% of 30 grams? 10% would be 3 grams. Half of 3 grams is 1.5. So you could be as low as 28.5, as high as 31.5. So did Judy make it to the low end of the range?
Are we there?
No, not quite.
Fortunately, not quite. But luckily, I still have one little left on my spatula. So let's add this in.
But let's look at her. Do you see the parchment paper there? Do you see a bunch left? How much started down there? How much did we start with? 33 grams, right? So scooping up everything she possibly could, we're down to 30.332, if you will, okay? So don't write that down, though, for your QA, because here's the deal. What haven't we done yet? We're almost done, but she hasn't finished dressing it yet. And in the dressing process, there might be a little bit of loss. You really do want to weigh it before you dress, because if she was already at 28.5, what would you want to do when you dress it? Almost don't dress it. Make sure you don't lose anything. Does that make sense? But she's got plenty of excess here that a little bit of loss as she's dressing isn't going to be a problem.
All right, so first of all, as Larry pointed out, you want to make sure your bottle is not greasy before you dispense. All right, I don't really have anything on the bottle. What you need to be careful is your glove. Sometimes if your glove is greasy already, it doesn't really matter how you clean. It's going to be dirty. So in the end, after you clean, before you dispense, take your glove off and check by yourself. Use your bare hand, okay? I do have a little bit on the side, so I want to clean that. Okay, that looks nice. So here, okay, how do I make sure that my top of this ointment look good?
Let me just say, do you see what the top looks like without it? It basically looks kind of mottled and everything else. We want it smooth with a little lip.
Okay, so how can I make it look even better? I think it might look pretty good already.
You have low standards.
How do I make it look even better? Okay, to fit Larry's standard. So your spatula, use your small spatula and go into a certain degree. How much degree are we talking about? Really depend on how much ointment or cream do you have and how close it is to the top of your jar. For me, maybe I need about 45 degrees. All right, your non-dominant hand is holding the bottle, your dominant hand holding the spatula. Okay, so watch me. So I want to use my dominant hand holding the spatula, my non-dominant hand holding the bottle, and turn at the same time. Have you seen this before? You ever cook in the kitchen?
Or iced a cake. The official term is just icing a cake. You're just smoothing down the top of the cream by lightly pushing on it. And by touching it in the middle and kind of quick pull up, kind of a quick pull up, you'll pull some of it up and make your little Dairy Queen lip.
Okay, so I made a little tiny curlicue there. Can you guys see there from the side maybe? All right. All right, I'm not quite confident that this is good looking enough yet. Because did you ever see something on the edge inside the bottle? So you want to use a piece of ointment paper, a piece of tissue, fold it in the corner like this. All right? And let's clean the inside of your bottle. has cleaned the inside of your bottle. Okay, I think that looks a lot better. All right, so let's measure the weight to make sure that it is indeed within the range.
So that will be your final QA weight. If you've done dressing it and that's the way you're going to put the lid on dispensing, then that's your final weight. So write down 30.167 for the final QA weight. Good. Okay, let me get back to this. All right, let's keep going, Larry. So let's finish the documentation. What we got here is you got your QA weight. We got a description. Remember, we're kind of crazy with our descriptions. So can we describe the color? Yes. What color was it? Yellow. I did whatever kind of yellow you want. I definitely have. It was yellow in color. Was it clear or opaque? Opaque. We want to make sure that it's called opaque. Did it smell? You couldn't tell from out there, but it has a strong scent. LCD does have almost a stink to it, so we did call it a strong smelling. And then the texture is smooth, okay? How did we make sure that we ended up with a smooth texture? We levigated the powder, right? So we don't want it to be chunky. We don't want it to be granular or like sandpaper. So, and then is it an ointment or a cream? Based off of the Aquaphor, it would be defined as an ointment. So this is a yellow, opaque, smooth, strong-smelling ointment. All of those levels of description. All right. We talked about the beyond use date. That was a 1 ounce, essentially, ointment jar. So it's a 1 ounce ointment jar. Because, wait a minute, how many grams in an ounce? 30, right? So we did the same container on that. So I'm just trying to remind you, last week when we made 2 ounces of a suspension, what size container did you put it in? 3 ounce, right? Remember, suspensions have an oversized container to allow for shaking. Obviously, you're not going to shake your cream or ointment, so that's not necessary. Okay. 2 things we want for the storage conditions: room temperature. So you'll just keep them at room temperature, and we do want an airtight container because you can lose humidity or absorb humidity depending on the base. So keep them in a tight container at room temperature. All right. The name has got a little trick to it. The drugs are pretty straightforward. It's drug name and then the strength. The strength is the percent, weight per weight, just like it's typically prescribed. So the drug names and strengths aren't bad. But there's 3 parts to the end. Okay, remember how we said the base does confer properties to it. So we include the name of the base. And remember, we're going to end with either cream or ointment. But where can you put a cream? Topically, certainly, but are there ophthalmic creams? Are there nasal creams, rectal creams? So we do need the rat, so it's got to be topical. So in the end, this product we labeled as in Aquaphor topical ointment. So those 3 parts to the ending there are important. Any one of those sections and you lose a point on that, okay? So drug name, strength, and in the name of the product, and topical, and you will be making topical. On the exam next week, it's the same thing you're making today, is going to be a topical product, okay? Lastly, the only sticker we're going to grade for on the exam is for external use only. Since you are going to be making a topical product, you would want to make sure the patient knows that it's for external use only. And that's the only one I'll grade for. However, would you agree, are ointment jars typically child-resistant? No, I think sometimes we take for granted some of the things we dispense that aren't in a child-resistant container. So it certainly wouldn't hurt to warn them about the child, keep away from children. But the only one I'm going to grade for is the external use only. Okay? Any questions on that? Wasn't that difficult? Good. Well, again, you're going to work on this yourself. I'm not going to do any calculations for you, but let's look at your wet lab. I want to cover a couple of things real quick just to make sure you are successful out there. All right? Your prescription is for Colleen Bontrager. She needs, also, again, you don't have to fill out the formulation record, so don't waste your time with the formulation record. I forgot to put it up here with this stuff, but it's basically urea 10%. And urea is a keratolytic. Kind of a cool word. You know what keratolytic means? Keratin, the top layer of the skin. It helps slough and gets rid of the basement membrane, so it kind of helps slough off the top layer of skin. So we have that urea at 10%, combined with triamcinolone 0.01%. And you know what triamcinolone is, right? That's an anti-inflammatory kind of steroid. And we're going to combine that in aquaphilic ointment, QSAD, to a total weight of 30 grams. All right? So under the additional information, things I would let you know there is to make sure you do base your calculations on 10% excess. I give you, again, the specific gravity for both glycerin and mineral oil. All right? So what do you need to know about this? A couple things. Fact that urea is a solid. It is a powder out there. So that's easy to deal with. You just weigh out whatever you need. But I'm telling you, it's very different than the hydrocortisone that I used up here was. And I chose urea specifically because it's very granular. It's almost like salt in terms of being kind of a granule, okay? Even if you levigate it with that particle size, I will see big old spots everywhere because it's a large particle size powder. So what do you need to do before you use it? Triturate it. And frankly, what you really need to do is triturate excess first. Just triturate some of it, then weigh from that the triturated amount. That way you don't lose any. If you weigh first and then triturate, half of it will get stuck in the mortar. And would you agree you're not making your cream in the mortar, so weigh it, triturate it already so that you get the right amount. Okay? The other major learning objective today has to do with the triamcinolone, because your source for triamcinolone is the 0.1% cream. Triamcinolone comes commercially available at 0.1%, and we have that cream. You're going to have to calculate how much of that cream to use to make your final product be what percent? 0.01%. Okay, so that is a calculation. You can do that several different ways. It's a straightforward algebraic way. Although another one that I'll mention that I like it. Once you kind of learn this, it's a real easy thing. Remember, there was a calculation, it was an A word, not the one from A, there's some other A word, that starts something where you have like a high strength up on top and a low strength in the bottom and something over to the right, and there's like these arrow things that you forgot from there. An alligation. So this actually solves really quickly if you can set it up as an alligation. And Judy and I would be glad to show you that if you want to do it. You certainly don't have to do an alligation. You can just solve it other ways as well. But I'm telling you now, this calculation is on the test. Whether I call it triamcinolone or some other drug, there will be some product that comes as a high-strength cream or ointment that you're going to have to figure out how much to use to make a lower strength for your prescription. So this calculation is important. Don't leave here today if you're not comfortable with how to do that. Okay, that was the big part of what we're doing. Okay, and lastly, aquaphilic ointment. Okay, that was on the list I gave you. So, and it turns out today you have a solid urea and a cream and another base. Is there any liquid called for in your preparation? No. So you're going to have to figure out which the two, whether it's glycerin or mineral oil, to levigate it with. So what kind of base was it? Go back if you haven't forgotten. Look on that little table you hopefully wrote down, because remember, aquaphilic ointment. Sounds like an ointment, right? So is it going to be mineral oil? Well, aquaphilic ointment is a what? An oil in water base. Okay, so which is your levigating agent for that? Glycerin. Why do they call it an ointment? I have no idea. That is the name of the product. You'll see it. Your jar says aquaphilic ointment, but it ain't an ointment. What I want you to do, I don't even know if that's a word, but open it up, look at it. It's white, it's soft, it's water washable, it is a cream. So essentially you are making a cream despite the brand name there being aquaphilic ointment. All right? So the other thing I got to tell you, since you are going to be levigating this, so you're going to have to figure out how much urea you are going to use. Do you know how much to levigate it with? So we already kind of said it's probably going to be glycerin since it's water compatible. Do you know the volume of glycerin to use to levigate it? No. So what are you going to have to do? You're going to have to figure out how much urea you need. Make sure you've triturated up. Put the urea on the pill tile, just like Judy did. And what I want you to do is go ahead and get an excess amount of glycerin. And I tell you that there are 3 ml syringes over there with no needles. I don't trust you. So just take a syringe, though. You're going to go into the glycerin and suck up 1.5 mils. Okay, I'm just giving you that for a range here. Start with 1.5 mils. Don't just add 1.5 mils, because 1.5 mils for this formulation I know to be too much. It'll make too runny a final triturated product. Okay. Start, though, with 1 mil. Instead of taking forever with this, start with your 1.5 mils in your syringe. Go over on top of your drug, add 1 mil, and levigate it. Okay? And then look at it. It will not be the definition of a what? 3 words did I tell you to remember? A sticky, you got it coming right. A shiny, sticky glob. We want a shiny, sticky glob. It will be wettish looking, but it will not be shiny, and it certainly won't be a sticky glob yet. So add 0.1 mil increments until you get a what? A shiny, sticky glob. Okay, and you should be still below the 1.5 by the time you're done. Okay, so by helping you with that, and you'll kind of figure it out. So here's the deal. Can you calculate how much aquaphilic ointment you need before you levigate? No, because you can start with the total amount with your 10% excess, subtract your urea, you can subtract your triamcinolone, but you don't know how much to subtract for the what? the weight of the glycerin until you've actually levigated it. So you're going to have to levigate based off of that volume, convert it to a weight, subtract that weight with everything else, then you can figure out how much aquaphilic you need. Okay, so don't forget or get confused about that part of it. So that's the only other thing, and that's why documenting your volume of that is so important. Okay, really, I think that's the main part. Go ahead, when you do all of this stuff, you go out there, do your own calculations, please. The calculations are posted in the supply station so that you can check, make sure you got them right before you do anything. You'll make your product. It doesn't take that long. Call us over if you want to know whether or not that really is a shiny, sticky glob. Judy and I are experts now at identifying that, so we'll help you with that. That's kind of a subjective aspect. When you're done, you'll have all of your product in your jar with your QA. Everything else needs to be documented. And last thing, I don't know you want to leave you. You will lose more points on your write-up than you will your product. These aren't difficult to make, so make sure you document everything in lab today so that when you come to check out, we are going to grade it like we would on the test, and you can hopefully not lose those points on the test. Bring over your product and your write-up, we'll go through it, and then you'll be on your way. So head on out there and do it.